Skateboarding. To some, it's a dangerous sport played only by fools. But to others, it's just a great pastime, either to relieve stress or just to have fun. But what if I told you those very skateboarders are people who manipulate physics every day to produce some amazing tricks? And here's my teacher, Mr. Mercer, to explain to you the physics behind skateboarding.
Hello, my name is Mr. Mercer, and I'm here in Oak Park High School, home of the Fighting Knights. We're going to talk about the physics of a basic trick. It's called the ollie. So once again, you have your skateboard, you're going forward, you're pedaling. What winds up happening is the friction of the ground actually slows you down, so that pedaling that you're doing, well, you have to keep pedaling harder. So for the trick itself, you have yourself center of the board, you have to slide your feet a little back, and you're going to apply force first to the back. So let's look. Your center of mass goes back. You apply force. That's going to be along that vertical axis. And once you do that, the back of the board hits the ground. It goes up in the air. You shift your motion, your center of mass toward the front, and that actually causes the front and the rest of the board to start coming back down. So it's motion along the vertical axis, and it's the force that causes it to actually go up in the air. And that's the simple ollie. There are a lot more tricks that we can talk about. The tray flip. So the tray flip's a little more difficult, a little more advanced. So what happens is same thing. So let's talk about the motion. You have your velocity, your forward motion. Same thing, friction slows you down, but this time, instead of just pushing straight down along that axis, what you're gonna do is you're gonna have rotation around that vertical axis. And when you have rotation around the vertical axis, that's actually your angular velocity. So you actually have to increase your angular velocity. So what happens is you apply the force down, but as you're applying it down, you slide and flip your foot, and it causes the board to give a spin. And it rotates right around that vertical axis. And so that's how we do the trick, the tray flip. Please, kids, don't try this at home.
Thanks for the explanation, Mr. Mercer. I bet some of you are wondering, wow, that's a really basic concept. However, those basic concepts are used in some major physics. I mean, it's quite literally rocket science. Now, let's use center of mass for an example. Center of mass, though it is a simple concept, it's used widely. And it's used in one of my favorite sciences, astronomy. Let's go back to the skateboarding example. We saw that center of mass played a large role in producing some of the tricks, such as the ollie that Mr. Mercer talked about. But let's put that on a bigger scale. Center of mass is also used in one of my favorite sciences, astronomy. Well, it's used to see the gravitational point between 2 points in space, such as the sun and the earth. Well, the center of mass in the sun, or the center of gravity, is in the center. However, when you compare it to the earth, well, the center of mass changes because there's 2 gravitational points between the two. Well, the gravitational point then is actually not at the center of the sun. In fact, it's somewhat outside the sun, because that gravitational pull of the earth is bringing it ever closer, but kind of bringing it far apart as well. Imagine it's sort of a seesaw. It's a center point. You have one side is the sun, other side is the earth. But since the sun's gravity and mass is so massive as compared to the earth, the center of gravity, or that central point of the seesaw, is closer to the sun. And that's just one concept. Really, you can find center of mass using a lot more sciences. I mean, heck, it's even used in astrophysics. I love astrophysics as well. Physics is truly amazing. It's so funny how you can get something so simple and make something so big out of it. I just, wanted to thank Mr. Mercer for allowing me to see how physics can be so big. He's the teacher that got me into physics and got me to really do this project. And I also like to thank Mr. Dirks, my math teacher, for allowing me to get some of the skating footage of him. And I also thank Khan Academy for providing me this opportunity to earn a scholarship from this video. And I'd like to thank everyone who was involved with the project, and anyone else, thank you. And thank you for watching the video.